List. I just kind of want to start out, we talked about Steel Connect EX and I mean, there's a lot of things that SD-WAN, it's just table stakes, right? Things that it does. But what I wanted to show you, I've got one of our 580s here. I onboarded that site as TFD EX20. And then I've got another site here that's actually down in Southern California at my place. Come on, mouse. And that's an Ontario EX. So I'm going to pop between the two of them just to show you a couple things that I think are kind of neat. And the first thing is, when you onboard, you think about bringing a device onto the network or migrating to SD-WAN. You're not necessarily going to be just ripping out every site and throwing SD-WAN in, right? And it's just greenfield. I mean, how often do you see just a greenfield network? Right? It's rare. So we always think about the brownfield. And, Steel Connect EX is template-based. So what's kind of neat about it is I'm going to leave this EX here, and I'll come back to them in just a minute. But I just want you to see you got some traffic running through it, and I've got some RDP sessions through here. But when I deploy this, I deploy it from a workflow template. Now, the workflow templates, these are a way to keep things consistent, right? So as I look at these templates, I have one that I called launch demo. It's a dual internet template. And as you go through and you set up a site, you start thinking about what kind of site this is. In this particular site, it's a spoke. And as I go through and I set up my interfaces, I define my two WAN interfaces, and then what those networks are going to be called, and you'll see that in the monitoring screen, how they're going to get their addressing, what's on the LAN side, that type of stuff. And then, of course, depending on what you're connected to, you might need to configure routing. So you can do that in the initial deployment template, right? So BGP, right, industry standard protocol. Same with OSPF. You can do static routes, all that good stuff. The next piece that's kind of neat is this is a branch office. This branch office, I'm going to have direct internet access. So when you talk about direct internet access, now you're talking about NAT, right? So I got to go through a NAT configuration. But using my workflow template, all I got to do is check this DIA box. And as I deploy it, it's going to build all that for me. Okay? And then services, at this particular branch, I want to apply a next-gen firewall. Because we talked about how direct internet access really, now, backhauling, that's how we did things. Now we want to use those internet circuits at the branches, but now we've got to secure the site, right? So I got to deploy a firewall there. So I can actually deploy a firewall right through my template, define my management servers like NTP, and then I deploy this box. So everything that you've seen here is exactly how I deployed this box and then that box that I have in Ontario. But now the interesting thing is when I look at these boxes, I'll just come over here to Ontario, and while I'm at it, let me show you a slide of what the network, part of the network looks like that I'm in. So right up there on the top, ONTEX, it's an internet-only site. Down here in the middle, I've got a Singapore site. I've also got a London and a New York site. And they're kind of the hubs, right? It makes sense because they're hybrid. Internet connectivity, MPLS connectivity. And then I got this Moscow router, 10.30.16.1, just a legacy site, right? So we got to talk. I should be able to deploy these and on day one, maintain connectivity in the network, right? So if I start looking at my routing tables, go into my LAN VR and filter for the 10.30.16 prefix. Okay, so I've got that 10.30.16 address, and the plus in the table, I've got two paths to it, but the plus in the table to the 16.0 is going to indicate my best route. So basically what I've got happening here, and this is just on a London site, which is a hub, which is probably the better place to explain this. The London site is pointing to a 169.254.04 address as its next hop from its BGP neighbor, right? And so then if I were to look at my BGP peering, and I look at that LAN VR, he's got a couple of peers. So here's the neighbor .4, which was the next hop to get to that brownfield site. Now you're thinking, okay, here's a BGP peering. Where's that go? Well, remember, virtual routers, right? So if I'm looking at my LAN side, and I know this is a site that's on my MPLS network, then that BGP peer must be the MPLS transport VR, and it's going to be B. So there we go. So my local address, .4, and then I'm peered up to .5. So that would be my next hop, and if I come into the routing table for that guy on the MPLS B side, and I look for my 10.30, .16, then he will have learned that from a 172.16 address, which is my MPLS, right? So I'm just throwing all these dots out here, and it's probably getting confusing, right?
Yeah.
But here's the beauty of it. When I deploy a workflow template, when I deploy this hub, for example, this London hub, and I say you're going to be a regional hub, let's say regional hub A, and I get to this point where I set up this split tunnels tab. I got to pick this, and then I can navigate away. Split tunnels. When I set up my MPLS side, all I do is I just tick this box gateway. The system knows now I need to build those BGP connections between the VRs, and I need to take those prefixes from the MPLS side, and I need to move them not only to my LAN side, but I also need to put them into the control VR so that it can be fed from the SD-WAN fabric out to those internet sites. Okay? So the point I'm making is that all of that complexity that I just showed that looked real difficult, it's actually not difficult to deploy. It's just a checkbox, gateway. If you have internet-only sites that need to talk to brownfield, you figure out where your hub is, and you check gateway, and it's done. Okay, so that's easy. But again, that's something that these guys should just do. The other thing that's kind of neat, and I'm trying to watch my time here. The other thing that's kind of neat is we talked about traffic steering and being able to control your path based on applications. So for that, let me go back in here to Ontario again. I'll just show you that one and give you an example of what I did here. So with Ontario, I wanted to talk to a server that's in Azure. So I have a gateway, SteelConnect EX deployed in Azure, and then behind it, I've got some servers that I'm going to VDI to, right? And for those, I want to make sure I'm doing some important stuff, maybe some CAD drawings or whatever. And so I want to make sure that I use those multiple paths that I have, you know, maybe 2 internet uplinks, maybe 4 internet uplinks, whatever the case may be at my branch site. I want to be able to watch the quality of those links, and if I start to see some latency, cut over. So what I do is I, of course, use the application detection capabilities to match the type of traffic I'm looking for. Just RDP is pretty simple, right? And then I write an SLA profile. So for this SLA profile, I just said, hey, look for 2% packet loss, right? Then I tie it to a forwarding profile, and this is where you get to tell it what you want to do. Now my SLA profile here, so that's looking for that 2% packet loss, right, that I'd configured over here under SLA profiles. I'm then telling it that I want to do something with this profile when that is violated, right? That's what I'm really looking for. If there's a violation, then do something. So what can I do? Well, I can decide to replicate across all 4 of those links, right? That's easy, right? So if the SLA is violated, then replicate packets. How many links do I have, right? So if I have 4 links, my replication factor 4. Start this when the SLA is violated. Stop it if I start to saturate that link above 80%, right? Back off. So it's dynamic, right? I want to evaluate it continuously. And then because I'm replicating across multiple links, I want to reorder the packets on the other side and make sure that they're all put back together in the right order. That's easy.
Why wouldn't you do that dynamically? Why do I have to configure that? Is there a license involved or something?
No, but I would think maybe I don't want to use replication, but I'd rather use FEC.
Right.
So So then if I want to use FEC, it's the same concept, right? Enable FEC, do it when the SLA is violated, and then what are my parameters for it? So you get to pick.
Yeah, but you're also assuming that the person doing the picking is competent enough to understand.
Yes, but I think you still need someone that knows what they're doing.
I would assume that the person configuring it is incompetent and that you should just make an opinionated choice about the faults. Anyway.
Yeah, I hear what you're saying. Other thing I could do in here, circuit priorities, right? So Internet 1's my first priority, Internet 2's my second priority. Flip them over to the other one if there's a violation. I can avoid certain connections. Another thing that's interesting is when you start to, let's say this is my primary link, and Internet 2 is my secondary, and I start to experience problems on Internet, and then Internet 2 takes over, but because I'm recomputing, Internet gets good again, and then all of a sudden it's not. Now you see the traffic go like this on Internet 1, and then gets bad, and then this on Internet 2, and then gets bad. But you can enable SLA smoothing, right, so that it's a more consistent flow of traffic across those two links. And you can also do SLA violation dampening, which is just like in BGP, right? If it's flapping too much, let's dampen it for a while, and then we'll let it, we'll bring it back after a decay timer runs out.
So when you do the load sharing, are you actually then just doing it per flow or per packet? Or are you doing per flow? Because it must be per flow because your SLA smoothing must be per flow.
Five tuple, right, per flow.
Yeah, per flow.
Yeah.
It's okay, it's not a problem. Just some people wander on about their per packet, but then the price you pay is if you're doing per packet load balancing, there's an impost CPU cost.
Yeah.
How much of what we're looking at here is from the Versa acquisition?
This is Steel Connect EX,
acquisition, sorry,
which is all based on the Versa partnership.
Yeah.
Yeah. Okay, so I set my forwarding profile, and then the last piece of that is go into a policy and set up a policy rule and define the source, the destination, right? You guys know how to do that. Come into your applications and say, I want to look for whatever app I'm trying to watch for RDP traffic. And then the enforcement is use my SLA profile to make sure that this traffic's controlled. And I apply it. And I can log it and monitoring and all kinds of other stuff. So that's the process to set up the traffic control. And like I said, you have a lot of different options in there. I'm just skimming the surface, but I just wanted to see some of the things that you can do there. So let's see. I talked about brownfield. I talked about the SLA policy. Right. So the order I was thinking here was that I now have traffic. Right. So I have my sites talking between each other. I've got my SLA policy to control certain types of traffic. Now we talked about, Roman talked about it, Dante talked about it, the SAS Acceleration. So let me just jump over here. Again, the part of the demo that you absolutely love is, let's see if this is still going to fly. Okay, here's PC2. So PC2 is a machine sitting in Ontario. Okay, PC1, this guy here, is also a machine sitting in Ontario. And I just want to go to my documents here in SharePoint. I want them to both be on the same SharePoint site. I have some large files in here, and I'm just going to download some large files. So what I did is I have that agent, okay? I'm sitting behind a Steel Connect EX, but I have the agent on PC1, and I do not have the agent on PC2, okay? So that's the difference. So I'm on PC2 right now. Let me just switch back and forth. There's PC1. There's PC2. So on PC2, let's do a little bigger one.
Do both. What the hell?
I know I could.
No, you can't.
Okay, so I'll grab a larger one. I'm going to download this. Okay, let's save it. And there we go. So we're downloading a 500 meg file. I'm going to do the same thing on PC1, the one that's got the agent installed. Hit download. Nothing happens. It's going to take a minute because it did this last time to me.
Click it harder.
I know, right? Try it this path. Download. How are we doing over here? 7%. We got time. Let's refresh. Okay, so we'll save it here. And I mean, it's moving pretty good. We could check the other side, 7%. So again, I mean, visibly, when you look at a machine with SAS acceleration, just pulling a file off of SharePoint versus the one that doesn't, it's drastically different, right? Now,
Is it working?
it's probably SharePoint being SharePoint.
Yeah.
Is it SharePoint Online or it's SharePoint?
Yeah, it's just SharePoint Online.
SharePoint.com. Yeah. If Azure's overloaded, it stops downloading regularly.
Yeah. So,
I know.
and I can refresh it, and again, it's vastly different when you look at the two. Now, the configuration of that, I'll show you that because Roman talked about it. You basically get access to the SAS Accelerator service. It's a service, right? It's a subscription service. So right now, I'm accelerating for Box and Office 365. And if I look at my data usage, for example, I can come in and I can start looking at Office 365 and see how much egress data I've seen there. And I can do data usage trends, and I can do the same thing for Office 365. And I can see what Office 365 data usage I've had and so on. But the neat thing about this is just how you bring it up, right? Roman said that you pick the SaaS app that you want to accelerate, you define your region, and you let it go, and it builds that cluster, right? So let's do it. I'm going to do this for, Dreamforce is here next week, right? So there's going to be a lot of Salesforce users. So let's do it for Salesforce. The region will be United States, and then number of users, right? So how many licenses am I going to provide for that? 200. There we go. And then submit, and there it goes. Automation in the background, bringing up that cluster of steelheads close to Salesforce, right? Yeah,
That's the head end.
the head end.
Yeah. And then the other end's distributed.
Yep, and that was where on that PC1 host, I had the agent installed.
So in this case, there's no, so most of the other people share. So my packet is segmented in the flight, but in this case, you're actually instantiating VNFs just for me to use. So there's no traffic or privacy or data sharing issues.
So the
You said
200
instantiating-
licenses
Yeah.
that I set up here for Salesforce, when you start accelerating Salesforce, you can have 200 users in your organization that are using that head end.
Right. But that head end is shared between me and whoever else is using it?
No, this is for you.
This is just the EX.
Just-
right.
yeah.
So the EX is a VNF somewhere. You're taking all those costs?
The steelheads
Yeah.
are, we're bringing them up wherever.
But they're not
right?
shared.
They're
What I'm
cloud-based.
saying
They're
is,
not shared. They're coming.
when Ethan's company says he's got 200 users and I've got 200 users, I've got my own EX.
Exactly.
Somewhere. It's isolated, so I don't have data sharing or GPDR or privacy issues.
Exactly.
At least in theory.
Yeah. No. Yeah. It is.
In
It is,
principle.
yeah. Because it's literally bringing up those
Yep.
right now for you.
Yeah.
Yeah. Yeah. So I'm not going to sit here and just wait on this while it comes up. It takes a couple of minutes, right, to run the automation. But that's how easy it is to just deploy that acceleration for those specific applications. We got a couple minutes. The one other thing that I wanted to mention was, two other things that would kind of be neat to mention. So we've got connectivity, we've got our routing going on, we've got acceleration, we've got SLAs going, and we've got direct internet access. We need a firewall. And I'm on the Ontario EX. I probably wouldn't do this at scale. I would probably configure my firewall in a service template, and that service template applies to a group of devices, right? The configuration looks the same. When I go into the next-gen firewall, I go under security, I look at policies, and now I've got all of my policies. You write them similar to an access rule. There's just more bits that you can match on, right? So, for example, if I just went into like this Office 365 rule, source and destination and all kinds of different things you can look for there, specific headers, the applications, And so I'm doing from our application detection, I'm saying find Office 365 apps, and then I'm going to allow this. So again, that's basically I've just created a firewall rule, nothing really special. But the point is I can deploy this through that service template, which deploys out to all my branches, and in a central location, I've secured my branches, but I didn't have to deploy another piece of hardware out there and have another management tool to be able to do that, right?
What's the filtering? What's the antivirus stuff? Is that a third?
So now you want malware protection, right? You want antivirus protection. You want URL filtering.
I want it for free though.
Now
So-
listen as he checks the box.
Yeah.
Wait.
Yeah.
Cha-ching!
Sorry, Brandon.
That's okay. No, that's okay. So you notice over on the left profiles?
Yeah.
So I could go in and write my own profiles for antivirus and all that stuff, but let me just take, for example, vulnerability. So there's a bunch of these that are built in for me, and there's a malware profile that does malware protection, right? So it's basically looking at the file and the hash and comparing that stuff, right? And once I apply that security profile to that traffic, now I'm filtering for malware. I
Network
do the same for
scanning,
URLs.
And that
you know-
profile contains whose malware, whose threat detection engine you're using.
And that's applying.
This is all part of the
that's applying
Versa partnership.
Okay, right. Okay.
to the stuff just that matched, in this case, the Office 365.
Just
So
Office 365, yeah. So you can be real specific to traffic that's only going to the internet and then not worry about other
Right.
stuff.
Yeah,
Right.
which is
Yeah,
a nice way of optimizing your resource usage.
yep. And then, of course, when you're doing all of this stuff, you need visibility. And so on board, we have analytics. And this is cool. I can just pop into analytics and I start seeing, things like security. If I wanted to go in and look at my firewall, traffic and start, seeing what kind of rules are most used and that kind of stuff. So this is just the onboard analytics that lets me go in and filter all this kind of stuff. And then access to all the logs and, all that kind of stuff. The other piece that's kind of interesting is Ramon talked about NPM, and I'm going to take 2 minutes of Vince's time. I hope he's okay with that.
Congratulations, Vincent.
It's how it always goes.
Listen, you pulled the last slot. That was going to happen. That's the way it goes.
So this is app response, right? So app response, part of NPM, this is actually running in Azure. So it's app response in the cloud. And remember, Ramon talked about like the tap. We can get data, packets into it, flows into it. So it's got everything, right? So we get flows, we can see stuff like this, But let's say like we had a workload and they said that things were slow, and it's a workload that's in Azure. And then I come in here and I see here's that Azure host that they're complaining about. My server response time looks kind of crazy compared to some of this other stuff. But if I right-click on that and I come in here, I can actually chart the response time composition. So it's looking at the packets to figure out, where these things are happening. And as I pop this open and I start looking at the different data I have here, it's pretty quick to see this is a server response time issue. It's not a network issue. So I can just say, okay, well, you're experiencing some delay. I'm done. This is the server, guys. And I don't have to throw more bandwidth at it trying to fix this problem because it's not a network problem in this case.
Storage problem.
And then the other cool thing about it is that, like let's say, for example, this particular client, 10.3.1.50, let's say I want to investigate actual traffic to and from this guy in a little bit more detail. I can launch Packet Analyzer Plus, and when I launch that, it'll open up my app here. And now all the packets are still out there in Azure in App Response, but now I'm looking at it from this app. Here's that host, and these are all the IP conversations he's having. And then what's cool is I can take this sequence diagram. Is this the right one? Oh, I got to actually select a session. There we go, like that. And drop it on here. And now I can actually get the full-blown sequence diagram, packet by packet, from this host. Come on.
Needs a WAN acceleration.
There we go. Right? So from that host, everybody he's talking to all the different types, TCP, HTTP, DNS, and then of course I can filter down into that, as deep as I want to get. I'm not going to take too much of Vince's time, but I can hammer down. But I'm seeing every single transaction, hover over it. I can see, source port, destination port, TCP stuff. And then if I wanted to, once I get to the traffic that I really want to analyze, I can pop that open in Wireshark or whatever you want.
What is the retention like on that?
It's a rolling buffer.
Sure.
So we have, on this particular appliance, we have 8 terabytes.
Yeah.
But, we have bigger appliances for,
This is all just based off of
This is 72 or something?
Is there like just a rough number for your typical customer for amount of data here? Are we talking like hours, days, weeks?
oh, yeah, thank you.
I would be more weeks.
Weeks,
Yeah,
okay.
weeks. So the big banks are using that for forensics, and they can keep it for few
Yeah,
months.
this information is great, but usually you don't hear about the problem within an hour, right? You always have to go back.
That's correct.
Being able to go back and do the replay.
Exactly.
You said you could export a packet capture from that as well.
Yeah, you pull the packets.
So all the packets, so you that's helpful.
Actually, what we do here is that we don't pull the packets. We are just browsing the packets, and once we have identified a sequence of packets that we want, then we can extract them and can use Wireshark
Yep.
and other tools for that.
Very cool.
Yeah. So again, it's just, what I tried to have come across as I went through this is the connectivity's there, right? That's the table stake stuff. And SD-WAN network's got to provide you that connectivity. But at the same time, it's not just the connectivity. It's improving the experience, right? So we make networks better, right, is the point, right? And give you the visibility you need to do that.